Sorry for that minor disruption. So I'll be taking the lecture on blockchain-enabled smart grid energy management. The contents of my next two sessions are going to be basically significance of the energy sector. We cannot deny that. Evolution of Indian power grids, and then what is the application of blockchain in Indian power grids and otherwise also, because not everything has been implemented in India. So we'll talk about the applications of blockchain for energy grids. We definitely know this is quite a popular slide. If I have to mention the most critical information infrastructures, energy comes at the first, for the simple reason that none of the others would exist unless there is a provision for energy to be supplied. Therefore, energy is the most critical infrastructure, information infrastructure of a cyber physical system which needs to be protected. And hence, blockchain has its own role to play in that process. If we talk about India, we are a very big nation, not only in terms of population, in terms of the complex power grid, the nature of the complex power grid also. We are amongst the world's largest power grids, energy grids, and we span over 32,000 kilometers from north to south and 2,900 kilometers from east to west, 3,200 kilometers from north to south and 2,900 kilometers from east to west. Such is the vast thing, and we have diverse population with different literacy rates. So there are good amount of challenges when you have to supply power to this wide population with different mindsets. Okay. In such a country, let us see how our power grid has evolved over the last 30-35 years. Not that before that it is not important. It is definitely important even before that, but the significant 35 years, last 30-35 years, they had made a path to what today we are discussing. Very initially, if I start from 1990s or before that, I mean 1991 and prior to 1991, our Indian grid was subdivided into 5 regional grids. Even till today, we operate as 5 regional grids: the northern regional grid, northeast, southern, eastern, and western. These are the 5 names of the regional grids. We are in the state of Maharashtra and this part of is the western grid of the country. What was happening back then, prior to 1991, was that Indian grid frequency, we are supposed to operate, we do operate at 50 hertz frequency. You understand 50 hertz, whenever you buy any electrical equipment, you can see its rating, 230 volt. If I plug in into that, it's a 230 volt single phase supply. This doesn't need an electrical engineering background. This is something, everything that I will be talking today is nothing to do with electrical engineering or the prerequisite to know about too much of electrical engineering. It is something that we are dealing with day in, day out. We, as a grid, we operate at 50 hertz. There are other countries which operate at 60 hertz. There is one country, Japan, which operates both at 50 and also 60 hertz. So there are such things. Overall, in the world, 2 frequencies are only operating. So that is why when you buy some equipment you bring from US or some other, you have an adapter which converts one frequency to other frequency. Now back then, before 1990s, we are supposed to operate 50 hertz, but each regional subgrid, okay, they have their own generating power stations, they have their own load centers. If you see this picture, we know that some of the major load centers of our country lies in southern India, Mumbai, Delhi, and to some extent Kolkata. This part also, this part also. So this part, I would actually say, is energy thirst all the time, even till date. Always it needs energy. How much ever you provide, it would need much more. Okay, northeastern part doesn't have so much of energy requirement. Again, that is still holding good till today. On the contrary, this is one side of it is the load requirement, the demand requirement, the power requirement. The other side is the generation. Who is generating you so much? Who is giving you so much of generation? Northeastern part of the country is rich in hydroelectrical power generation. And there is also at this part you have coal mines, Talcher, and other parts. You have many coal mines across the country. So I would just try to say that there are different sectors of the country where some places demand is high, energy demand is high. At some places, energy generation, power generation is high. So you will have to transfer that high power generated from one location to other location, because of which Indian grids have multiple voltages. You all know that this is the least voltage. We are operating at 230 volt. You have 11 kilovolt, 33 kilovolt, 66 kilovolt. The transmission tower lines that you see, they are much higher. India's highest voltage is 765 kilovolt. It is in AC. You all definitely know we have AC and DC. We operate in both AC and DC. So AC is 765 kilowatt, DC is 800, plus minus 800 kilovolt. World's largest, or first, I would say, world's first multi-terminal HVDC link is in India. Anyway, that may not be relevant at this moment, but that was the case. 50 hertz we are all supposed to operate, but each subgrid operated at little minor variation, plus minus 2 hertz. It's not a joke. Some grid was operating where energy requirement was high. It was operating at 48 hertz, and some fellow was operating at 51 hertz, 52 hertz. It went up to that. So this is a very dangerous thing. 50 hertz plus minus 0.5 hertz is acceptable. Even till date, a grid code talks about 50 hertz, 49.5 hertz to 50.5 hertz is an acceptable band. However, we have become so beautiful and today's date that we operate even in lower bandwidth is much smaller. Okay? So the point is that this was the condition way before 1991, where subgrids were operating at different frequencies, and to transfer power from one subgrid to one regional grid to another regional grid, there were issues because you cannot transfer synchronization. There are other electrical issues. So eventually, what the country has decided is that they have at a distribution sector, there is a lot of indiscipline, but we are talking about a transmission sector. That point in time, they have introduced a very important tariff, penalty-based tariff, which is called availability-based tariff, frequency-based tariff, availability-based tariff. That was one mechanism, and unscheduled interchange, second important mechanism, which helped grids to become more disciplined. Transmission grids very particularly. So in 1991, what happened was the eastern and northeastern, this entire thing was made into one. Okay, they started operating in synchronization. 50 hertz or 48 hertz, 49 hertz, both were operating at the same frequency. So they were united, I can say. Subgrids do continue, but still they are operating in synchronization. Then in March 2003, this entire sector, the central, the eastern, northeastern, western, eastern and northeastern, everything started operating in synchronization. In August 2006, the entire northern grid operated in one synchronization. And on December 31st, 2013, or tomorrow morning is 1st January 2014, our entire country has become one grid, one nation, one grid, and one frequency, which is 50 hertz frequency. So this happened in a way, I can say, 1st January 2014 or 31st December 20, that midnight, we have synchronized the entire Indian grid. It's a big thing, okay? Because when we talk about a country with this vast population, diverse mindsets, people and grids, managing a grid of this magnitude is not a joke, okay? It is quite challenging, and we really don't even understand sitting at here, okay? So this is the magnificence of the Indian grid. If I talk about the installed capacity of our grid, we are 47%, we are thermal based generation. Okay. These are the numbers taken from existing January 2025 data was only available. So just made a pie chart of it. The coal base is 47%, and then solar, wind, hydro, biomass, nuclear, oil and gas, small hydro. Altogether, if we have to say, this is the thing. So renewables, we are not bad. We are actually growing at a good rate. Say 7-8 years back, 10 years back, the numbers were different, and the rate at which we are growing on renewables, both wind and solar power, is magnificent. Almost 45% of our generation is through renewables. When I say renewables, I mean wind, solar, biomass based, except for coal and nuclear power and gas, diesel, that rest of the things come under renewables, because they are as such not emitting carbon dioxide, right, green gases. So this is our condition, okay, as on today. So as I proceed further, I want all of us to understand that for a successful electrical grid operation, there are mainly 3 entities we need to take care, protect, secure, where excess data exchange is happening. Sector 1 is generation sector. Sector 2 is transmission sector, power transmission sector. Sector 3 is distribution sector, power distribution sector. This college comes under power distribution sector because I am eating the power. After someone distributed, Goa Electricity Department has distributed the power, and NIT Goa, this room, is eating it, consuming it. So we are a distribution side, on the distribution side. So this is the fundamental, and we need to protect every entity. There are so many components involved in it. Power generating station, or you call the transformers. You definitely know all these things you see in, day out. The transmission towers, the lines, the protection systems, physical systems there. There is a lot of physical systems involved in that, and their security. There is a lot of data exchange happening. All of them needs to be taken care, okay? So in the traditional grids, what happens was, generation was on one side, transmission system was, so whatever you generate, okay, you are going to send it through a transmission grid and make it reach the distribution grid. At the distribution grid, you have residential customers. See, at the distribution grid, you have residential customers, then you have the commercial users, and you have the industrial users, agricultural users are also there. There are many varieties of people. So the power flow, generation was happening somewhere here. This is prior to renewable integration into our grids. 20-25 years back. Actually, I should say prior to 2000, year 2000, this is the condition of the country, where all these generating entities were owned by state power utilities and central power generating companies. They are called generating companies. Is this banging like Baz? Something? Fine. Okay. So they were owned, they still own. Majority of the shares are owned by state governments and central governments. Okay. You would have heard about national NTPC. How many of you heard about NTPC? National Thermal Power Corporation Limited, National Hydro Power Corporation, NHPC, then NPC, Nuclear Power Corporation of India Limited. So all these things are the central government owned generating stations. State government owned generating stations are also there, depending upon the size of the state. Anyone from Maharashtra? Okay. Gujarat? Rajasthan? So your state is rich in which power generation? Solar is rich. Yours? Okay. What are they? Right. And in Tamil Nadu, people are there from Tamil Nadu? No? Okay. You have your nuclear power plant? Yeah, from where? Neyveli is not nuclear, it is coal based. Neyveli is coal based. Okay. Karnataka? Talcher, no, sorry, Talcher is in Orissa, Kolar is in Karnataka. We have many nuclear power, thermal power plants. Hydro is little. Maharashtra, you will know, Koina is one big source. Gujarat has a lot of Sardar, well, that Sarovar is there, and so many so forth. So what I am trying to say is that way back, these generating entities were owned by either state government or central government, and they were transferring, and these were located distant locations. You will not be able to have a hydropower generation in NIT Goa. Where is the water stream? And you need a height for energy for the water to fall from higher potential to lower potential. In that process only energy gets generated. We'll not get to the mechanism of how power gets generated, but I'm just trying to say that the geographical location also has a wide importance. So that power which was generated was being transmitted over bulk networks and reaching the customers. This is where we had. There were issues with this. Issues, as I have just told, or either I have highlighted them as features. This entire thing is centrally owned, centrally governed, either state entity or central government entity was owning these power generating stations. The transmission networks, state transmission utilities or central transmission utilities were owning them, and distribution companies of the state were owning the distribution sector. From there you and I buy power. This was the condition before 2003. So it was centralized. The power flow is unidirectional. I can say left side to right side. In the diagram wise, it is unidirectional power flow. There was no scope for prosumers. Prosumers are consumers of power who also produce power. The rooftop solar people are a good example of prosumers. There was absolutely no scope for prosumers, right? And then there was very less scope for renewable integration. When I talk about renewable, I will definitely not talk too much about how things work. Fundamental thing, the issue with renewable is that if I am a coal thermal power plant owner, I will be able to very conveniently tell you next 1 month how much power I can generate and give you. How will I be able to give that 100% assurance unless my generator has gone for some unexpected thing? But if everything goes fine, I have the required coal reserve, the tons of coal I have, that gives me the confidence that for the next 1 month I can generate so much of power and put it to the grid. But if I was a wind farm owner or a solar farm owner, I will not be able to make this 100% assurity. For the simple reason that I might have the installations of those wind turbines, my solar farms, well maintained, everything on good, all good, but still the way clouds would move, the way wind would blow at what speeds, at what point in time, all these things are not in my hand. It probably is not in anyone's hand. The best of the best forecasting algorithms, generation forecasting algorithms, be it wind-based, be it solar-based, who can forecast when the cloud is going to come, whether, however best also, still it is not 100% accurate. Not only Indian forecasting, it's the international level also. Whoever is doing the forecasting, none of them will be able to give you 100% accuracy. So many times we get to see now, rains have started today, and the 2 days it is raining. We get a report that so and so, 5th day from now, it's declared yellow day or a red alert or a yellow alert, and on that day rain doesn't fall. How many times have we observed that? Many times. Okay? No one has given any wrong information, but that was what the prediction was. Okay? Actually, when it was red alert, there was no alert. They expected that it's going to become more and more severe. By then, it has subsided. This is quite common across. Okay, you take the best of the best forecasting algorithms, high power computing machines, still these chances of becoming 95% and above accuracy is still a question to be answered. Okay, so the point is that this was the condition, and therefore there was less scope for renewables. Renewables are intermittent sources. I just want to keep this one word in your mind: intermittency, unexpected, unpredictable. whenever you are students who tomorrow would be working on an application of blockchain or cybersecurity with an application to electrical domain. So when you get to hear this word intermittency, electrical engineers use it like day in, day out, because we deal with highly unpredictable sources. So therefore, intermittent sources, there is a lot of issues with that. Okay? And then sensors were less sensors we handled, therefore less data also captured. Intelligence was relatively less. Most of the time, some blackout, brownout would happen, and after that we used to do postmortem analysis. Okay? And self-healing was actually, word also did not exist. I would not say not exist. We do circuit breakers for auto reclosure breakers were there, but it's all to a limited extent. This was the condition in the traditional grids, which were just 25 years back in our country. So these were the challenges. There was centralized control, lack of transparency, costs were high, and trading was not there. There was no trading only. I own the generation, he owns the transmission, they own the distribution, that's it. You buy from me, it's a monopolistic system. Okay, I am the monopoly, right? So now, after that, what went lovely was that Electricity Act 2003. Okay, this privatization of electricity happened in 2003, where open access was facilitated. Same thing, similar things happened in other sectors also. Telecom sector, you remember the prices of who they continue, of course, but who were the only monopoly in telephonic sector, telecom sector earlier? Only monopoly. BSNL and MTNL. MTNL was for specific regions like Delhi and Mumbai, I think. But BSNL, all across the country, only BSNL was there. You know, there were times, probably your parents would have seen those times. By the time you tried to make a wireless communication, you had a phone on your hand. There were times when midnight 12 to morning 6 o'clock, the prices were 50%, and the other time it was pretty high. STD calls, local calls also. Earlier, if I make a call, I am anyway charged even till today. Of course, now the systems have completely changed, but the one receiving call also was charged. Okay, even there was a, I'll not name the company. I started ringing you, from now I am being billed. You didn't pick the phone, but from the time I started giving you a call, the billing has started. There were such glitches also. Anyway, these things were handled and things are much better today. So the competition is very healthy, it's important to a good extent. But there should be one government agency also to make that modernization, right? So when you talk about the smart grids, where after Electricity Act 2003, we have enabled privatization of electrical sector. A blockchain would not have existed if this electrical power trading or privatization did not come into picture. We started, electricity till then was a particular service, but after 2003, our country identifies electricity as a commodity, which is sold by someone, bought by someone. It's a commodity now. It was a service, it continues to be service to some extent, but it's a commodity at one level. Okay, I am a generating plant of some nature, I am selling it at this price in this block period, and someone is there who wants to buy it at that block period, and there is a market settlement happening and a price is obtained. There is a mechanism. We'll not definitely get into that because that won't be of your requirement. So in this system, there is a bidirectional power flow. I am a prosumer, I have a rooftop solar. I can also inject power into the grid. I can inject power at a different voltage levels, and I can consume. There is too much of bidirectional flow of power is there, because of which electrical protection systems also had to become more intelligent. Not only bidirectional flow of power, there is huge amount of data that is getting captured. Okay? Now, once you have huge amount of data, that data is used to run high intelligent algorithms, high computational power requirements are also rising. The system is expected to become self-healing. It should be predictive in nature. It should predict based upon the variations in the voltage. Electrical engineers, for them, the ECG, heart, how heart is working fine or not, you come to know based on the ECG report. One of them is that. Okay, similarly, for an electrical engineer, our electrical grid is healthy or not. We see using two things, voltage, frequency. Voltage is fine, things are fine. Frequency is fine, okay, everything is fine. Okay, so these two are the measures to say that electrical grid is in good hands, is safe. Okay, so all these things are there. It's a decentralized system. You have private parties also who has come into picture, generating transmission distribution companies, and you have that bidirectional flow, good scope for prosumers. You have, very initial stages when rooftop solar installations were put into place. States like Karnataka, Tamil Nadu, they were giving 9 rupees per unit. You know what is 1 unit of energy? 1 kilowatt hour, 1000 watt hours. Okay, if I sell 1000 watt hours to the grid, I am getting 9 rupees. I am talking about the initial stages. Now it has little come down. Okay, so sitting at home, I am able to provide power to the grid, and I am also earning in the process. That is why it become a prosumer also. Financial side also is there to it. So these were all facilitated in the modern grids. Lot of intelligence is anyway there. This is all perfectly fine. Okay, so what is happening because of this? We understand that these are the 3 important pillars: generation, transmission, distribution. In these 3 important pillars, there is huge crucial data which is being recorded and also further handled or processed. Okay, crucial means crucial. I not because I'm an electrical engineer, because I need electricity for my survival, I would name it as a crucial crucial resource or an entity. So therefore, when you are handling such crucial data, the data that we are capturing or recording is through the current and potential transformers, remote terminal units sitting at different substations, phasor measurement units, there are again an improvised versions, intelligent electronic devices, huge number of sensors, and many, many more. These are all some of the devices which are capturing the data continuously at some rate, okay, at some rate of data capture. So when so much of data is coming into picture, you have to ensure the data's privacy and security. We all very well are aware that there is a lot of involvement, or someone is trying to peep into our data, manipulate it, and give you a different picture. Today, my voltage condition is bad. But if you are the operator who will control this voltage condition by doing something, and you are not given the right information, then you will not act upon it. And my condition would deteriorate, and one day I will experience a blackout. By then, you will not understand, everything looks to be fine on my screen, how come there is a failure on that end? So your data, huge data, it has to be secured as well, and that is where blockchain comes into picture. We have many examples. This is all just a to all that. So data privacy and security is very, very important, because this data, whatever we are capturing, they are going to do very big jobs. They are going to be run into a lot of AI, machine learning algorithms. Okay, these algorithms are going to classify the kind of problems that they see. Support vector machine, these are some of the things all of us do understand. A lot of ANN based, okay, fuzzy, much earlier fuzzy was there, genetic algorithm, and today we have so many bio-inspired algorithms, okay, all possible animals are already in them. So all of these things are required, application to application, not that everything suits every application, every algorithm suits every application. Application to application, the algorithm would definitely change. So this data that is there, it is processed, used for fault detection, and take the key. So here, this is the place where when you have to maintain the data privacy and security, when you have to maintain this, and this directly talks about cyber security aspects, blockchain is going to take a important role, would play an important role when you have to manage this huge data, which is going to take very fundamental decisions for your country. We all know that any disruption in a country would affect its per capita income. If industries shut down, all these things would affect your per capita income. So it is that important to maintain. So if you see the architecture, it's a big drawing. I will not be getting into everything, but you need to understand that there is something called as a physical layer, wherein your actual physical devices are sitting, generation side, transmission side, distribution side, and lot of things on a physical level are there. There are devices connected to Internet of Things. There are lot of sensors, electrical vehicles, okay, and many things are there. This is at the physical layer. All of them have sensors, okay, data recorders, which are going to send information to a central control center, which is actually called as SCADA, Supervisory Control and Data Acquisition. SCADA is not specific to electrical thing. Any industrial control, any automation is there, SCADA comes into picture. You can have SCADA for water pipelines and many other things. Okay, so this is a physical layer. You have a cyber layer where lot of sensors are there. They communicate this data to your SCADA center through some communication, wired, wireless, even power line cables, PLCs, and a lot things. So this is your architecture. So definitely, you definitely understand one thing. There's a lot of data. There are a lot of sensors capturing them, and there is a lot of communication happening between them. All of them cannot be unauthorized access to any of this is not accepted. Okay, only authorized people should see the data and understand, take decisions on that. So let us understand all these trends. Last 7, 8 days, you are hearing the fundamental aspects of the qualities, the features of blockchain. All of those features of blockchain, decentralized peer-to-peer trading, smart contracts, transparency, maintaining security, integration, scalability, all these important buzzwords which determine a blockchain are highly required to run an efficient electrical systems with this smart involvement. So applications would be in many things. Peer-to-peer energy trading, and energy trading is in many sectors. It's not just from generating plant to transmission or distribution sector. Everyone is now a trader, a seller. I am also a seller if I have a rooftop solar. Okay, if I have electrical vehicle, still I am a seller. That is the way in which we are moving into. So trading is going to be taking excessively, and then IoT, again we have lot of sensors and mobility, and so these are some of the applications, just a few applications. Actually, if I have to give you the big chain of applications, this slide would take care of it. There is data and need to have a blockchain based mechanism for security using in each of them. Okay, generation, in each of them, their forecasting, their maintenance, transmission sector also, asset management, distribution sector, all the assets. We have assets of every sector running into crores of rupees and years for installation also. It takes time also to install. So therefore, the asset management, outage management, microgrid controlling, meter data management, your smart meters, electricity meters, their management so that pilferage doesn't happen. Things are automated. If I'm a highly influential person, I may not pay the bill. COVID time, we had so much of recovery of the bill because we have banned some nodes. People have paid most of the bills. Not most, but people have paid bills. Okay, and they are not poor people. They are rich people, but they won't pay because of some influences. There can be such reasons. If you are automating things, then it's not in anyone's control. All right. Therefore, so all these things are very much possible. These are all applications in the power sector. As a customer, if I see, I can have all these applications of resource sharing, billing, electrical vehicle related things. We will spend good amount of time on electrical vehicles, e-transportation in many other ways also. Then local maintenance of microgrids, demand side management. In the market operation, you have a lot of trading is there from everyone to everyone. Then greenhouse gas trading, carbon certificates, these are some other things, service providers also, and control and operation also. So in every sector, I would say, you have a possibility to make it secure, more intrusion free using blockchain technology. These are some things which I will not be able to highlight everything, or more or less they are connected also. So these are peer-to-peer trading, automation, metering, carbon certification, and all these things. When I talk about any of the application, underlining cyber security aspect is there in everything. I don't have to talk separately about cyber security. I take any trading, any data exchange, there is a hacker sitting there waiting to spoil it. Okay? So cyber security is a layer which is there inevidently. These are our power of blockchain which we will be using, and to ensure that we have trust, security, and accountability in our digital records. So we will start with one by one application now. Okay? Let's talk about the first application, peer-to-peer energy trading. I am very specific to my examples for India, because first of all we should know where our country is. In India, 2008, June 2008, we have made electricity a commodity. National Stock Exchange, we know, where shares are bought and sold. Electricity, 2008, June 2008 onwards, electricity has become a commodity which is sold by some authorized people and bought by some authorized people. Okay? And the two power, it happens through an online platform, definitely. And those platforms very initially is Indian Electricity Exchange. This is the website, you can go through it. And Power Exchange of India Limited, PXI, XIL. So these were the two initial platforms, power trading platforms, which exist till date, which enabled us to do power trading in the country. And in 2021, we have Hindustan Power Exchange Limited also, which has come into picture. This is more a latest one. After COVID, this has come into picture. But these two existed for good amount of time. Okay? And these are some of the markets, power markets you can bid on. Okay? You should be eligible. There are eligibility criteria. Fulfill them. Okay? At least you should have a 250 kilowatt unit and things like that. If I am a prosumer of a rooftop solar, I will not be able to do this. Just because I will not be able to do a trading transaction on this site. These are at a bulk power level, not at smaller level. Typically, a house will have 5 kilowatts, 10 kilowatts. There are sanctions up on that. 10 also, no? 5 kilowatts, most of them 5 to 7 kilowatts. Most of the Indian households I am talking about. Okay? So these are all the tradings that happen in day ahead markets, green day ahead markets, high power markets, real-time markets, intraday, interday, contingency markets, and so many things. So you can do trading of power, buyer as a seller, using these. Okay? There are also times, everyday time. I will not be detailing much into that. So day ahead market, it started from this 10 a.m. to 12 noon, 15 minutes. When you have to trade for power, 15 minutes blocks are created. In a 24-hour in a day, how many 15 minutes are there? Can anyone quickly answer me? 24 hours of the day, how many 15 minutes are there? 96 15 minutes are there. So when I am trading power, I am trading for 96 blocks of time zones. 12 to 12:15, 12:15 to 12:30, 12:30 to 12:45, and so on and so forth. Okay? 15 minutes block is what you trade for. Because 15 minutes, if you really commit, today I am committing, I will give you so much of power, 15 minutes on a particular day, or day ahead means for tomorrow. I should be able to adhere to that power that I have told I will give you. I will inject into the grid. And you have bid to buy power, you should also buy that much power, not more, not less, at the best. There is some deviation allowed, but at the best you take that much power. If you take more power, my frequency will reduce. If you take less power, my frequency will increase. And if I don't do anything, my fan, 50 hertz fan, this is a BLDC fan, of course. If I talk about any other frequency thing, then that is going to have issues. Okay, voltage and frequency issues arise. So point is that you have these time zones which you do trading in India. So the entire process of blockchain, when you superimpose it on the power trading in this is what is the flow. First of all, you initiate a transaction to sell power or buy power, which is verified by your network. I think you are more knowledgeable than me on this, but I'll quickly tell you the life cycle of this. So you have getting it verified by all the miners, and then once the transaction is approved, consensus mechanism is done, then you add this block to the chain of thing. Once the transaction is completed, you are saying go ahead, and the power transfer happens or whatever things. And whenever there is a change, you know that there's a procedure which has to be fulfilled. And every time there is a change, you have a new block that is getting added. This is the fundamental philosophy of how blockchain works. It is not easy to tamper it so easily because so many people has to give an approval consensus. So there are a lot of things when it is put on a blockchain. Many applications you're anyway seeing every day. Today is the electrical day. Hope no one gets shock. Electrical shock. Okay. So this is another way to say about the same thing. You can carry out market settlements. You can carry out state estimation. You probably wouldn't understand what it is. Very, very important to ensure that the data captured is correct. That validation is done through a procedure called a state estimation. Energy trading is going to happen, and then the market initiation and all that. So simple words, if I have to see the difference between the traditional power trading, you have your generating companies, you have your distribution companies. Most of them are talking about electricity flow and payment flow. Data flow need not happen because there is centralized control. Data flow is not that rich. Now in the new scenario, everything goes through, everyone communicates with the blockchain and the trading platforms, everything. Here the payment is automated, therefore you don't have to break your heads. Blockchain ensures a payment mechanism on its own. So we are not giving too much importance as a flow. Information is flowing, power is flowing, payment is happening. There is no issue with that. So this is the difference. After renewable, acha, sir, should we take a break now? 5 minutes?